Alrighty, let's take a look at our homework for 1.1.3, starting off with the M&Ms. This is a review of the 5D process. For those of you that were here in 7th grade last year, you've already got them in your notes and you've practiced them quite a bit. If you are a transfer from another Loomis school, then you've seen the 5D process because all the Loomis schools work with the CPM math program. And it's possible if you transferred into our district from another district, if you'd been using the CPM math program in your previous school, you'll already have seen this. But if not, the 5D process is simply a process in order for you to go through to be a good problem solver, essentially. So the 5Ds start off with describe or draw. So when you're reading through a problem, you pull out the essential information and you determine what is the question asking us. In the case of geometry-like situations, sometimes it's good to draw the picture. Other times, you're just writing out the essential information. Then there's the define. The define portion of the 5D process basically tells us to identify what variables we know and which ones we don't know. And the ones that we don't know typically are the ones that we have to solve or figure out. Then we decide on a process. Are you going to use a guess and check process to get to your answer? Maybe set up a table. Maybe you can create an equation based on the information, and then you would do the problem. After you do the problem, you look through your work and you say, hey, does that make sense? Maybe we should check it. And you decide if the answer is correct. And then once you've decided the answer is correct, then you can declare your answer. So this is what all problem solving is about. CPM happens to call it the 5D process, but if you've learned about problem solving in 5th or 6th or 7th grade in a different school, you still were going through these basic steps to solving your problem. It's just a matter of being organized with your work. And we're going to have a problem toward the end of this homework where I can walk us through that 5D process. All right, so let's go on to problem number 19. It says here, use your graphs from problem number 17. That would have been what we were doing with the algebra walk in 1.1.3's lesson. And answer the following question. It says, how can the graph for the rule y equals 2x plus 1 be used to predict the result for an input value of 7? How can the graph be used to predict an output value for 3.5? Well, the answer to that is if you want to have an input value of 7, then you'd go on your graph to where x was equal to 7, and then you'd figure out, okay, what is the y value for this? Now, to me, it's easier just to use the rule, right? You know, it's going to be 14 plus 1 is 15. But let's see, do we have that a graph here for 2? Yeah, so you'd go here, you'd have to go to the 7, which would mean you'd go all the way up here. Now, we were running out of room for this graph. This is why graphs aren't always the best for making predictions. Rules are the absolute best. But that's what you would do. You'd go to where x is 7, then you'd go all the way up to where y is equal to whatever number that is, which in this case is going to be 15, and then you'd just see it on the graph. And then for an output for input of 3.5, this one we'll be able to see on the graph. Where 3 would be here, so 3.5 is going to put us right around here. So that answer is going to be somewhere around 8, I think. We would have to extend it. Once again, this isn't the best graph for that because the y values only go up to 6. And so anything beyond basically x is equal to 2 is not going to be on the graph. If you wanted an output of 7 for rule y equals negative x plus 4, what would you need as your input? Okay, so we could set that up. If you want 7 to be the output, then what does the input have to be? Well, we would have to figure out what number you're going to plug in there, right? So maybe this part where the math is a little bit complicated, maybe it is nicer to have the graph. So we want an output of 7, right? So let's go to y equals negative x plus 4, which is this one. If we want an output of 7, which would be right here, that means that your input would have to be what number? It looks like that's going to be right around negative 3. If I were to solve that, let me just go ahead and solve the problem for you. We take away 3 from each side, so that would end up being, oh wait, no, it's supposed to be a 4, isn't it? let me change that. Okay, so we would take away 4 from each side, so this would be 3 is equal to the opposite of x. So the opposite of x is 3, which means x has to be equal to -3. Okay, and part C, for each of the rules, identify where the graph crosses over the y-axis. So these are what we would call y-intercepts. On every one of your graphs, we've got a line that extends and will go through the y-axis. And this point right there is where y is equal to 1. This is where y is equal to 0. This here is where y is equal to 4. This here is where y is equal to 4. And then on the parabola for y equals x squared, this is where y is equal to 0. So those are the answers. These are all the y-intercepts. Remember, the y-intercepts are where x is equal to 0. So this would be the ordered pair that you would write in for each one of those y-intercepts. Okay. All right, now we get to use the 5D process. I'm going to do some highlighting to help us. This portion right here is sort of what we would call a describe and a define section. Hey, goodness gracious, it's not writing very well. Those are horrible dotted I's, but you get the idea, right? Okay, so let's highlight. Jabari is thinking of 3 numbers. Wonderful. The greatest number, okay, so we've got a greatest number, is twice as large as the least number. And the middle number is 3 times more than the least number. So as I'm looking at these, I'm noticing that, no. What happens if I do this? Does it black it out? Okay, that's not too bad. It looks like both of them are being compared to the least number. So I'm going to make the least number be my variable, which I will call z. I don't know why I chose the variable z here, but I did. And so the middle number has to be 3 more than that. So this would be z plus 3. And the greatest number is twice as large as the smallest number, the least number. So that would be 2 times z, because that's what it means for twice, 2 times. So what we got here, these are the expressions that we would use. And these are the definitions. That's how I define each one. Now, the do section is over here. How are we going to solve this problem? Well, we know here from our last little bit of information, the sum of the 3 numbers is 75. So we need to add all of those numbers together, but we don't know what any of the numbers are, so we're going to add the expressions to represent each one of those unknowns. So here's your 2z that gets added on to your z plus 3, which gets added on to your z. So we'll combine like terms for a total of 4 z's plus the 3 equals 75. And now we start using algebra. Let's take away 3 from each side and then divide each side by 4. And that means that the least number had to be 18. The greatest number is twice that, so that has to be 36. And the middle number is 3 more than this, so that would be 21. So this is how we're going to decide if we've got the answer correct. Let's add these together and verify that they add up to 75. So 14 and 1 makes 15. Carry the 1. That's 4, 5, 6, 7. Yes, it does. I've done the decide portion. And now I can declare my answer for all 3. Okay, so that looks a little bit different than what the 5D process template looked like in the math notes in the M&Ms, but it's the essence of it. You're showing your work. You're not just guessing at what you're supposed to do with those numbers and having sloppy work all over the place. Someone else who looks at the problem and looks at your work can see exactly how you got to where you got and how you declared your answer. All right, so let's take a look at this. Letitia's friend Brandy forgot to take a makeup test and had these scores: 80, 92, 91, 75, 89, 84, 0, and 85. What is her mean? Well, how do you find the mean? You add up all the numbers, and then you divide by the number of numbers. So 1, 2, 3, 4, 5, 6, 7. There are 8 scores here. Even though one of them is a 0, that's going into her overall average. So her overall average is 74.5 and a half. By the time you take the sum of all those numbers and divide by 8. does this score really represent her abilities? And my answer is no, not really, because that 0 is an outlier. It's messing up the overall average. If she got nothing below an 80, oh, I guess she did have a 75, didn't she? But still, her average here is lower than the lowest score of all the tests that she actually took. So that was a little bit wrong. It should be 75 or higher. So now when you add on, she gets a chance to make up that test, right? She got a 78. So now we plug that 78 in instead of 0, and notice how her average increased by 10 points by removing that outlier and replacing it with something that fits into the data set. So what difference did the 0 make? It brought her average down tremendously, correct? Now let's take a look. Remember, we talked last year about the difference between median and mean. Let's find the let's find the median of all of these scores and see if that doesn't get us pretty close to this average. So we take the lowest first, then we'll take, and actually, no, that's the lowest, isn't it? Then 75, and then we've got an 80 and an 84. And then there's an 85. So we've got the 80, the 84, the 0, the 85. The next one would be the 89. Then you got the 91. And then finally the 92. So 1, 2, 3, 4, 5, 6, 7, 8. Our two numbers in the middle are 84 and 85. So whenever you've got two numbers for your median in the middle, you take the average of those two, and lo and behold, they come very close to our mean. The average in this case, or the median average, is 84.5%, which is only 1/4% higher than what her mean was. So this is a great illustration about how when you have an outlier, it affects the mean, but it doesn't affect the median. So in this situation, you'd be better off for the average being the median. But once she took this test and you plug that in and replace all of these, I guess the median is exactly the same because that would go here and then this one would go out. 78.5. So you still have the same median, but the mean matches it. So when there isn't an outlier, go ahead and use the mean. Generally, that's the best. But when there is an outlier, you can mitigate that by finding the median. And I believe this is our last problem. No, it's not our last problem. Got a couple more to do. How long is this taking us? Well, a little bit of time today. Okay, so an area of a rectangle is 24,396 square centimeters. If the width is 38 centimeters, what's the length? Okay, so 5D process, I'm just going to draw a rectangle, right? I don't really care if these are proportional dimensions. We know that the width is going to be 38 centimeters. We don't know what the length is, but we know that the average, which is what you get by multiplying base times height, is going to be 24,396. So let's replace the area with our 24,396, and then we'll replace the, I guess, the base. We can call that 38. It doesn't really matter where these two numbers go, but here you see 38 times something gives you 24,396. So that something has to be, or 24,396 divided by 38, and I fully expect everyone to just go ahead and use their calculator for a problem like this. We are engaged in problem solving. I'm not assessing you on your ability to divide. So go ahead and use your calculator for that, and we can declare our answer. The length of this rectangle has to be 642 centimeters, which is not even close to being proportional here, but whatever. All right, and now the last problem, being able to plot these points. These are all rational numbers or rational number expressions where you can find the value of each one of them, and each one of them has a home on the number line. Starting with A, it was provided 2 1/3 is approximately here. Negative 2.7 is between -2 and -3, but closer to -3, so this would be B. 9/10 minus 4/100 is 86/100, so C is going to go between 0 and 1, but closer to 1. D is going to be between 0 and -1, but closer to 0. And then 1/3. 33 1/3% is the same as 1/3. That would be 1/3 of 12 is 4. So that E is going to go here. And then the one that required us to do a little bit of work, 7/10 times 2/3, you'll need a common denominator. 30 is the best multiple there. So we can multiply 3 over 3 times 7 over 10 to get 21 over 30, and 10 over 10 times 2/3 to get 20/30ths. Now they have the same denominator. You can add the numerators, and this is going to be a number between 1 and 2, almost halfway. If it was 1 and 15/30ths, it would be 1.5. So it's a little bit less than 1.5. So go, find the halfway point and go a little bit to the left of that and label it. All right, so that took a little bit longer, but still some good review of concepts that we learned in 7th grade and what we've been working on so far this week. So good job. Make sure you're always copying your problems, showing your work, and making the corrections if you make mistakes. Okay? All right, take care. Bye. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk